Welcome back to Math 103. This is video number 9 on apportionment. Last time we ended by looking at a variation of our recurring example in which there are 21 seats in the New England legislature instead of 25. And we're getting used to this new idea of standard divisor. So the first question was, without computing the new standard divisor based on 21 seats, do we think that it should be greater than the standard divisor with 25 seats or less than the standard divisor with 25 seats? If we think about standard divisor as average population per seat, then it should be greater. That's because fewer seats and the same population require more people per seat. In other words, more people living in each congressional district. To compute this new standard divisor, we compute total population, 13.9 million, divided by number of seats, which is 21. Just to be precise, I'm going to indicate units here. 13.9 million people spread out across 21 seats, and that equals 661,995 people per seat. Okay, those units are worth keeping in mind. So in the previous example, it was only 556,000 people per seat. Now it's over 660,000 people per seat. Right? So there are more people per member of Congress now, as we expected that there would be. Alright, so we're building some intuition about what standard divisor means, how it's related to our problem. Let's look again at something we observed earlier about the Hamilton apportionment for this 21-seat version of the problem. We observed earlier that New Hampshire, which received 2 seats, which is to say that it got rounded up. It received a surplus seat from Hamilton, compared to Rhode Island, which got rounded down, had very different numbers of people per district, per seat, within the state. Right, so in New Hampshire, we observed earlier that there were 600,000 people per seat, right, 1.2 million people spread out over 2 congressional districts, whereas in Rhode Island, all million people lived in 1 district together. Right, so in New Hampshire, the district was much less crowded than in Rhode Island. We already knew this, so what does this have to do with standard divisor? Well, this number right here, this 600,000, this is less than the standard divisor, which was over 660,000, and this number right here is much greater than the standard divisor. In other words, the standard divisor gives us a basis for comparison. The states in Hamilton's method that are receiving a bonus seat, a surplus seat, are going to be less crowded within each congressional district, and they're going to have less than the standard divisor number of people living in each district. Whereas in a state like Rhode Island, which was rounded down, it received only its lower quota, the districts are going to be more crowded. The number of people living in each congressional district there will be greater than the standard divisor. Right, the standard divisor is the number of people who would be living in each congressional district if they were really all the same across all states. Right? They're not the same across all states. Within a state, the same number of people live in each district, but from one state to the next there are differences, and the standard divisor gives us something to compare to. So this leads us to an important principle that's worth putting a box around right here. Every apportionment method, not just Hamilton's method, but the others that we're going to study, strives to make the population per seat within each state close to the standard divisor. Right? So here, arguably, our method did not do so well. We ended up quite far away from the standard divisor, and the people in Rhode Island are mad about it. Okay? But at any rate, that was the hope. Ideally, every state would have a number of people per seat that was exactly the standard divisor. In any apportionment problem, no matter what context it arises in, it's useful to interpret what the standard divisor means concretely, in terms of average population per seat, whatever population means in that example, and whatever seat means in that example. So before going on to the next video, give a concrete interpretation of what the standard divisor means in each of the following examples from other contexts than politics. For example, in our first item on the list here, where we're allocating buses to bus routes based on riders, what does the standard deviation mean here? Well, here it means the average number of riders per bus. Okay. Notice that we are not mentioning states when we express the standard divisor in terms of the language of the problem. Right? Standard divisor means population per seat, average population per seat. So in this case, average number of riders per bus. I really emphasize this because students make this mistake. Sometimes they think it means the number of buses per route. That's not it. Or the number of riders per route. That's not it either. It's the number of riders per bus. This is analogous to the number of people per congressional district.